Hi, welcome to this lesson on t-tests. In the previous lesson, you learned about your first statistical test, the correlation analysis. In this lesson, we'll be exploring one of the most common statistical tests out there, the t-test. This test is done when you want to compare two means. This is done all the time in HR. The difference in performance between two similar departments, or the difference in engagement scores within the same department at different times. For instance, pre and post management change. It's a statistical test you need to understand to be a fully functioning data analyst. So with that said, let's get started. Let's say you've recently conducted a proactiveness training for two departments and are pleased with the results. However, you have a feeling that the training had a larger effect on Department B than on Department A. You want to measure whether these two departments differ in terms of proactiveness and thus set out to collect your data. You've randomly selected 16 participants, 8 from each department, and set them down to fill out a survey that will measure proactiveness. After they've filled out the survey, you calculate the mean and standard deviation. On a scale of 1 to 10, Department A got a mean proactiveness score of 7.6, and Department B got a mean score of 7.9. So we observe a difference between the two proactiveness scores, namely a 0.3 difference. But is this difference a real difference? Or could it be that the difference simply appeared due to random chance and that the two departments in reality do not differ from each other? That's where the t-test comes in. So first, we create a null hypothesis. A null hypothesis is there is no difference in proactiveness scores between Department A and Department B. And our alternative hypothesis, Department B has a larger proactiveness score than Department A. Now that we've set up our hypotheses, we can perform a t-test. Specifically, we'll do a two-sample t-test, also called an independent or unpaired t-test. This applies as we are working with two distinctly different departments. And it's also called independent or unpaired t-test as scores of Department A have no effect on the scores of Department B. This is the formula for the t-test. You can calculate this by hand, but most statistical programs will do this for you. To summarize what the statistical program does for you, you're creating a t-value that corresponds to the difference in mean between the two scores, divided by the pooled standard deviation of both departments. The pooled standard deviation is the average spread of all data points around their group means. It is a weighted average of each group's standard deviation. Alright, so say you've got one group. You pull this group apart and place them in two separate groups. How will you now prove that these two groups are the same? You do this by comparing the difference in means between the groups with the difference in variation within the groups. These are in this example the same, so there is no difference. This is how the t-test works. The t-score is a ratio between the difference between two groups and the difference within groups. The larger the t-score, the more difference there is between groups. The smaller the t-score, the more similarity there is between groups. A t-score of 3 means that the groups are 3 times as different from each other as they are within each other. When you run a t-test, the bigger the t-value, the more likely it is that the results are significant. So a large t-score tells you that the groups are different from each other, whereas a small t-score tells you that the groups are similar. Now in our example, the t-score is 0.438. Not that large, unfortunately. Corresponding with this is our p-value. Our p-value is 0.6684. If you remember correctly, our cutoff point for p-values is 0.05, as that was the predetermined alpha level for most social science studies, including ours, and we are conducting a one-tailed test. Anything above that, and we failed to reject the null hypothesis. As 0.6684 is above 0.05, we fail to reject the null hypothesis and thus have to conclude that the difference we see in the two means is due to random chance. However, this independent t-test has a big flaw. Due to the random sampling, and especially the small sample size, your design did not account for the fact that some people are simply more proactive than others. Department A might simply have more people in them that are more proactive than normal, which allowed for the means of Department A and B to be closer than expected. To account for this, we often use a paired sample t-test instead of the unpaired two-sample t-test. This alternative test allows you to pair two people who are very similar on the variable you're testing and then randomly assign them to the two different test groups. For instance, if we had the chance, we will pair two people who are similarly proactive and put one of them in Department A and the other in Department B, This would reduce the pre-existing chance for a bias that one of the departments simply had more proactive employees. Due to the fact that there is now an equal variation in the amount of proactiveness in both groups, you will reduce this bias. Unfortunately, in our case, people are already assigned to their respective departments, and we can't change that just for our test. Furthermore, paired sample t-tests are often done in another way, namely by matching a person with him or herself, because the best match for a person is, of course, themselves. This is often done at 2 different times, so you can compare the same person at 2 different times to determine if any change has happened to your test statistic in that time. That is often done to determine training effectiveness. The first measurement is at the pre-training, whereas the second measurement is at the post-training. You can then analyze the difference on, for instance, customer service satisfaction by using a paired sample t-test. Let's take the following data. In the following data, we have a customer satisfaction scale from 1 to 10. Each person is measured at 2 times, both at pre-training as well as post-training. We expect that people will score higher on their post-training when compared to the pre-training. Thus, our null hypothesis is that there is no difference in customer satisfaction between pre- and post-training. The alternative hypothesis is that there is a difference in customer satisfaction between pre- and post-training. When we compute everything, we can see that the mean difference is 0.18, whereas the average variation is 0.05. This gives us a t-value of 3.21, which in turn gives us a p-value of 0.006, which is significantly less than the predetermined alpha level. Thus, we can say that the difference between pre- and post-training was statistically significant, which means that our training was successful. Good job, trainers! Finally, you also have the one sample t-test. This test allows us to compare the sample mean with a predetermined mean that is associated with the null hypothesis. Think back to our example in Module 1, where we wanted to know whether the 9.5 hours worked by our employees after a managerial change is significantly different from the 8.5 hours that they worked before. Our null hypothesis is therefore HO is 8.5, whereas H1 is larger than 8.5. Now, before you run off and start your t-test, there are a few assumptions all t-tests have to adhere to. They are: the data needs to be on a continuous scale. The second one is independence of observations, which means that your participants do not influence each other's scoring. If your research design is proper and the participants are randomly selected, you will often satisfy this assumption. Third, your data needs to be approximately normally distributed. This is not a hard assumption, as your data can deviate somewhat from normality, but the more and more skewed it is, the more you have to take the results with a grain of salt. Fourth, there are no outliers in your data. If your data adheres to these assumptions, you can perform your t-test. Once again, here's the decision tree for when to use which statistical test, in which you can now recognize the t-test. So that's it for this lesson. In this lesson, you learned about the t-test. In particular, you learned about the independent sample t-test, the paired sample t-test, and the one sample t-test. Finally, you know what assumptions your data needs to meet in order to create statistically valid results. In the next lesson, you will learn more about the ANOVA test, another commonly used statistical test. I'll see you there.